Hello and welcome. We appreciate that you could join us, and I do hope you are having a top-notch day. So I'm your host, Charles Collegy, the security analyst for Accelerated Strategies Group. Now, today's Devops.com webinar is brought to you by Synopsys. And today I have with me Simon King, the VP of Solutions at Synopsys. And he will be speaking on making AppSec tools seamless in DevOps pipelines. Simon, if you could say hello to our audience.
Good morning, good afternoon, wherever you are. Thanks, Charles.
All right. And I know Simon is eager to fill you all in on how Synopsys Intelligent Orchestration simplifies the integration of static and dynamic security tools within the CI/CD pipeline. However, the meat of today's webinar must be delayed a few moments to allow me to handle the housekeeping items. Please note that this webinar is being recorded. Later, it will be available on demand. So you will receive an email with the link, but at any time, you can go to devops.com to gain access to this and all of the archived on-demand webinars we have available. So feel free to peruse the webinar library. I want to take a few moments to comment on the Big Marker platform we use. First, on the right hand of the screen, you will see the chat button. This feature allows everyone online to interact during today's session. Say hello. Let us know where you're from. Feel free to provide any comments and feedback. We'd like to get immediate feedback. We want to hear from you. It will help direct some of the comments, I think, in the future, what you are looking for. Now, if you have questions to ask, please don't use the chat, because sometimes if we have a lot of chat going on and you place questions in there, they could get lost. So put the questions in the Q&A tab, and when we get time at the end of the event, we will try to answer as many of the questions that you've submitted. Now, if we're not able to get to those questions, I'm sure Synopsys will follow up. You will also see a handout button, and here is where you can download the additional information that Synopsys has made available to you. Lastly, I do want to make a comment that if you just want to see the slides, you can run your mouse over the slide panel, and where you see full screen, click on that button and it will isolate just the slides. Now, the most important housekeeping item is at the end of today's webinar, we will be awarding 4 $25 Amazon gift cards. So please stay with us till the end to see if you are selected. But now it's time to jump into today's session with Simon King. The floor is yours, Simon.
Great, thanks, Charles. Welcome, everyone. I'm Simon King. I'm based in California, so despite my accent, I actually live in California. I'm based fairly close to San Francisco in the heart of Silicon Valley. I've been working in the Valley for about 23 years now, and I've had a variety of roles. I've worked in the software industry all along. I've worked in QA, development, product marketing, product management, even technical support. I've worked in a variety of roles at a variety of companies. I've worked at Borland, which some of you may remember, early days, C++ compilers, Pascal compilers, even Quattro Pro and tools like that. Progressively, I've moved towards e-commerce, so very early days of e-commerce, worked on a platform for personalizing the way that marketing and sales works. And through the course of my development, I've moved more towards operations and focused back on development. So now today, I run a team that manages the products within the Synopsys Software Integrity Group. The Software Integrity Group carries a variety of tools to help developers build secure, high-quality software. And what I want to do today is really focus on how 2 of the very latest additions that we've added to our portfolio. These are products that we've added in the last couple of months of this year. Intelligent orchestration is targeting the ability to integrate AST, application software testing tools, right into the continuous integration and continuous delivery pipeline. It's designed to optimize how those AppSec activities work. And then for all the data that's generated from those tools, CodeDX is designed to aggregate that data and present a composite view of all the different testing that's done and provide high quality prioritized feedback directly to developers. This allows developers to really just focus on the high priority things, the things they need to fix now and soon, and then allows AppSec, the app security team, to enforce policies. So the purpose of my talk today is to introduce the tools specifically, to talk about how they work with tools that you use in CI/CD and other app security tools, and to show how you can use them together to improve the way that developer security occurs. Let's start just for background. I think thinking about the conundrum that we face today in app security, applications are the #1 attack surface. Working in this space, in the security space, it's just so clear the extent to which all of the products that customers build, organizations build and use are under attack. Whether it really doesn't seem to matter anymore whether you work at a meatpacking factory or in a hospital or in some critical government organization. The apps are the #1 attack surface. And the result of that, the implication of that, is that we need to make sure that applications are being tested in many different ways to ensure that the risks are not exposed, the vulnerabilities are not exposed to the public internet. Meantime, the business is demanding, the organization is demanding that we release software faster, which is great, but it does mean that there's a real implication that testing needs to happen seamlessly. It can't be hard or an extra step to run, and it can't take a long time and delay the feedback to developers to say, hey, you need to fix this before we push to production. And lastly, the C-suite is becoming increasingly involved. In the past, they haven't really worried too much. The individual teams, they agreed to set up teams for app security, define product security champion processes, fund that training, etc. But increasingly, organizations are being required at the executive level to really worry about, do we have the right security program? What's our liability? What risks are we taking on? And what are the best ways to mitigate those? So we must be able to turn the findings across all of these different tools and activities into impactful activity, whether it's identifying that, through threat analysis, what new particular attack modes might exist, and then ensuring that we have testing to mitigate risk of vulnerability there, or as software is being developed and before it's moved into production, driving a vulnerability back to development, stopping the build to make sure that that doesn't go into production. So there's a real conundrum here. On the one hand, we're all under attack, we're trying to go faster, and we need to be more disciplined than ever in making sure that we're keeping track of all the different issues. And the real underlying problem as DevSecOps teams work through these issues is that many of the tools we're using weren't really designed for this new DevOps paradigm. I'm showing here on the screen a sample pipeline. This is based on a pipeline of one of the many customers that we work with. We find customers have dozens of different kinds of pipelines and many hundreds of instances of those pipelines. And across the top, you're seeing the development path from requirements to dev to build to functional test, unit test, etc. And then progressively, as binaries are generated, then a controlled and gated flow through into production. Some companies are letting the development teams directly move containers and other binaries into production, true DevOps. Others are still less comfortable with that, and they have a gating process. So you see across the bottom in this instance, this is a sample bank where they've got controlled propagation to higher environments, dev, sit, UAT. The challenges that DevOps teams tell us that they're seeing is that they're trying to manage the integrations between too many tools that run at different speeds and certainly don't necessarily match the cadence that they're trying to run build through the pipeline, so they're too slow for development. Some of the tools were originally designed for application security, and they're too complex. So they need to be simpler, particularly if we're going to have interaction directly with developers. And many of our customers are not just pure play software companies. They're not software companies that were born in the cloud. They're not Uber. They're not Netflix. They didn't design straight out for DevOps. They didn't design straight out for AWS or Azure or Google. And so therefore they have multiple different SDLC variations, software development lifecycles, for legacy applications, for newer applications that are web-based, and then for truly, cloud native serverless functions and things like that. And the AppSec teams themselves then complain, hey, with all this tooling, it's really hard to get a unified risk view. How do we do that? The way they do it often is with manual tooling, taking extracts of data in Excel, aggregating that data by hand to present the view. And again, that doesn't match the cadence that the DevOps pipeline is trying to run at. I have customers in banks, for example, that are doing 300,000 releases a month through one pipeline. I talked to an organization last week that works in the college area, so not necessarily the education system we don't always think of as being that modern. They had 35,000 Lambda functions. They had 650 build pipelines. So this idea around pace and scale is really one that we weren't originally designing for. So how do we address that? How can we help make this easier, more scalable, easier to use, and mitigate the risk within the pipeline? What we're proposing is the idea of what we call intelligent orchestration. So intelligent orchestration is a way to take the events that occur within the development pipeline, file save, pull request, code merge onto a feature branch, propagation of a feature branch onto a release branch, take those events and feed them into an intelligent system that looks at the context in which that event occurred, and based on policy is able to decide what kind of test should be run. Should I do static analysis on code that I ran? Should I do dynamic analysis on an API or a binary? Should I interactively test that binary with the functional test suites that I already have? Or do I need to look at the open source that's included in the system? There may be hundreds or thousands of open source components in a modern web application. Which ones are meeting my policy compliance if I'm an ISV? Which ones are aging and have vulnerabilities, or a brand new vulnerability pops up that we didn't even know about and we don't have a release already scheduled? How do I know about what's going on in open source? And indeed, it's not just about the tools that Synopsys creates, but there are many tools that either you built or you're leveraging from open source that you want to be able to run to make sure you have a complete view of risk. So let's take a look at how that can work. Intelligent orchestration is a set of Docker containers that matches the kind of modern CI/CD pipeline in terms of how it's deployed. So whether that's in a virtual private cloud, whether that's on-prem, you can deploy these containers and it just simply plugs in to your CI/CD pipeline. It connects to GitHub, to GitLab, to Jenkins, to CloudBees, a variety of different tools with simple APIs and plugins that connect right into the CI/CD tooling that you built, and then abstracts the kind of testing that you want to run. So that allows you in your CI/CD tool of choice to define where to hook into the jobs or tasks that are being run in the builds and where you want security tests to run. And then you're just simply calling intelligent orchestration and it will figure out what to do and it will go do it. So it eliminates all of that custom scripting associated with, when a pull request occurs, then do this. So that's a big key piece, is it really simplifies how to connect the tools right into the pipeline. If I think about how many tools there may be in the pipeline, in this example, which is a real world example, I've just changed all the names to protect the innocent. There's over 25 tools here. As a DevOps team, if you just changed one tool every 2 years, 25 tools divided by 24 months, that means you might expect at least one tool change per month. maybe none this month and 2 next month. So there's always change going on in the pipeline, and that's hard to manage. So eliminating this custom scripting and abstracting those calls to the different tools really facilitates that flexibility that you want in the pipeline. The second piece is that when you write that custom scripting, you're defining rules about what to run, when, and how. And so what intelligent orchestration does is it defines policy as code. When this event occurs, think about doing this kind of testing. When you look at the context, so for example, how much code was changed? What is the nature of that code? Does it have open source in it? Was there 1,000 lines of change or just 10 lines of change? It uses that data, that context as input to decide what to run. So based on the nature of the change, based on the nature of the risk associated with the API or application, is it outside the firewall? Is it only inside the firewall? Does it contain personally identifiable information? All of these facets can be used to decide whether or not to run a test. Have you had vulnerabilities that were critical in the last 30 days? If yes, then maybe that team needs a little bit more help in the testing. So we define policy as code to define what kind of testing, static, dynamic, etc. And then separately abstract what tool is used to run static, dynamic, etc. So one application built in Java might use one particular tool set. Another one running Swift might run in a different tool set. So we clearly abstract that in a very simple way using YAML files to define policy as code. So the policy can be checked into your source repository. It can be versioned. It can be tested. You can create a new pilot pipeline to test changing over a tool. One of the many tool changes you may be doing, it allows you to test that in a separate pipeline without disrupting everyone else. So once those risk scores are running, here we've got an example where a code change has been made and the risk score was calculated based on the nature of the change, and it came up with a fairly high score, 67.25. Based on my policy, I've defined that once I see a score that high, I am going to enable changes. And in this case, it's deciding that perhaps this is a fairly risky API, the nature of the change is fairly critical, and as such, it's defining a fairly broad set of tests. It's using Coverity in this case for static analysis, Black Duck for open source analysis, using a third-party tool, Zap, along with Seeker for interactive testing. And then it's in a container, so Aqua is enabled for image scanning. So you notice it's able to define a range of checks based on the level of the risk and maximize the opportunity to check while minimizing how much testing is done unnecessarily. So the real objective is to optimize the testing. There's not enough time and resource to run all tests all the time. And even if you did so, that would slow down the feedback to developers. So what we want to do is optimize the risk scoring and the actions to get quick feedback that is relevant to the developers. So once the test has been run and executed, the results came back, those checks may include observations that we're not comfortable with. So the systems allows configuration of the workflow back to developers. So again, you're not having to write custom script when dealing with workflow. You can just define policies that say, if I observe 2 or 3 criticals, raise a message in the Slack channel and wait for interactive input to decide whether to pause or proceed with the build or the deployment. So we're able to define manual activities that could be an approval, or it could be a manual pen test that's triggered based on the nature of what was found. So this allows us to tune how the SDLC works, including out-of-band tests and manual activities. Again, without writing a line of code, you're able to integrate those normal behaviors, exceptions in this case, right into the flow of the SDLC. Policies within that workflow can then take over, and you can say, one of the other key challenges we hear from customers is, I'm running multiple checks, I'm aggregating the data. How do I handle the case where I want to decide whether to release the software? In this case, what we've done is we've put CodeDX in as part of the pipeline to correlate the results. So CodeDX is designed to take inputs from over 75 software testing tools and to incorporate that data, to aggregate it and use it to correlate the results, and then provide a view that lets a risk owner, somebody within the product team, if you have a structure where the ProdSec owner, the risk owner, is within the product team. Other teams have it set up so that the AppSec team signs off. But either way, you can have formal sign-off based on a complete view, an end-to-end view, a holistic view of risk. So this, again, is a key way that you can incorporate aspects of policy within your SDLC and automate them. Do it at the pace of the CI/CD pipeline, that is to say, automate the data aggregation, and do so in a way that automates the sign-off so that you've got a clear record of what was done and who signed off on it. So I started referring to CodeDX there. I want to talk a bit more about CodeDX in terms of what problems it's trying to solve and how it goes about solving them. So CodeDX is a unified AppSec reporting tool that generates data about what it found in all the testing that was done. It's an analytic system that enables teams to really go at the pace of their DevOps pipeline. CodeDX is taking over the manual activity of running tests, capturing the results from all of those tests, normalizing the test results. So it defines rules that map static analysis results, dynamic analysis results, open source analysis results, and normalizes the prioritization of the findings. It's able to deduplicate. So you may be running multiple static analysis tools, and the system is able to deduplicate the same finding from different tools, so reduce the amount of noise in the system. Then it's able to correlate them and see which ones are similar in the caused by the same kind of cause and effect. So correlation is something that's very time intensive. We have machine learning built into CodeDX that automates the process. It learns over a course of weeks and months of observing data what the patterns are in terms of correlation of findings and what actions the security team take based on the nature of those findings. And it uses that data then to feed a risk prioritization, a complete view of risk based on all the testing that was done, including third-party AST tools, including Zap, Findbug, Sonar, SonarLint, whatever you're using, custom tools that you've written. If it's got an API, you can define the policy by which it gets run in intelligent orchestration, and then execute that test and aggregate the results. And that can include the manual testing, the code reviews, the threat models, the pen testing that's done by third-party service providers to feed a complete view of the software package, help you decide whether it's ready to release. When you aggregate the data together, there's a set of things that teams normally do by hand. They run the tests, they get the data from those testing tools, and they aggregate them together. They generate the results and then format them into reports. You have many different tools, and the formats from those tools are quite different, so there's a lot of manual work associated with organizing them into a common format. And indeed, if you're running them, every day, every time a major build is done, there's a lot of data that's repetitive, meaning you already knew this. It's noise. You've decided you're not going to fix it. So you already know that you've triaged it and determined we're not going to fix it this time. So reducing that time to normalize and triage and prioritize the results for development is a key aspect here that just takes manual work out of the system. There's no value add. Obviously, it's important not to feed noise back to developers, but in terms of redoing the same thing over and over again, this is like RPA for reporting of risk across all software projects. The other key activity that CodeDX is able to do is answer the question about what software was tested, what was found from those tests, and track whether it was fixed, if it was fixed, and when it was fixed. So these are things that as an AppSec team, we absolutely have to have a handle on. So the system is running, there are builds flowing through, developers are making changes, findings are being fed back to the developers, critical findings are being developed, tested, and incorporated into the release. And from an audit perspective, am I following my policies? Am I able to comply with my policies, ensure that I comply with them? And will I survive an audit? CodeDX provides the repository to track all of that activity. So in intelligent orchestration, we keep a record of all of the events in the CI/CD pipeline, what the recipe was that was defined, test this, that way, and then the results in CodeDX to say, this was tested, here's what was found, here's what was determined. So this is a significant saving in time and effort to help teams run at the pace of the DevOps pipeline. Another piece that we note is that there are a couple of different ways that teams are organized. So we're finding that some AppSec teams are set up as a kind of as a service bureau. So basically, they're not a large team. They're providing services to the development teams where developers own security. They've got embedded, prod security champions in the developer teams. Developers are responsible for making sure that they've defined how they're going to implement policy and that they are following it, and then at release time that they have met those criteria. So in that case, CodeDX gets deployed by AppSec and made available to these development teams, product teams, to ensure that they have a record of what they did and that they followed the policies as intended. Another model we see is where the AppSec team is more engaged, like they've kept that activity more into themselves. So here they're actually doing the work of providing that support directly around reporting and feedback to developers of what to fix. So in that case, what it allows the AppSec teams to do is to support more projects with the same number of people. So it's a way to help scale the AppSec team. So kind of in both cases, we're trying to support the speed at which the developers want to run and do so in a cost-efficient manner by automating that activity. Now, part of that activity is we go beyond just thinking about aggregation of data. I mentioned earlier that we normalize the data by vulnerability type. So on the left-hand side, you can see there was a number of different tools that have been run. Under that list, in the list box in the left window, you can see Coverity was run. That's a static analysis tool. And Seeker was run. That's an interactive tool that runs. It's an agent that's installed against the back-end web server. And when you run normal testing, either by hand or with automation, Seeker is able to track vulnerabilities, information leakage, weaknesses in the software and report them back. And on the right-hand side, we're seeing a range of different findings that have been normalized. There's a number of SQL injections, a number of cryptographic issues, and you can see that the different tools are intermingled. That is to say, the system is identifying the top two purple critical issues, and then in red, the high severity issues, but then normalized for impact based on vulnerability type. So this is something that otherwise would take a lot of manual activity to figure out what's what from the different tools that were run. And if you're doing that every single day, every single build, every single check-in, that's really time consuming. And whilst on the one hand, it's really valuable just to provide that clear feedback to development, it's a lot of manual activity that's just very repetitive. So the other aspect is then, organizing things by severity. So here, down in the lower left, we're able to filter by severity and just look at the criticals and highs. I often find when I work with project teams that are shifting from either manual approaches to AppSec or they've used some simpler tool in the past that's not as robust in terms of the kinds of findings that it generates, some of the tools that Synopsys sells, Coverity, Black Duck, Seeker, etc. We provide very robust checks with deep analysis of the software, the open source, and the running binaries and APIs. So the quality of the data that we generate is very high. If a customer is switching from a lower level set of tools to these more sophisticated tools, when they first run them, there can be a lot of findings. And so it's really helpful to be able to really hone in on the criticals and highs, the cross-site scripting, the SQL injection, vulnerabilities that they may not have known are there, and they want to really focus the team on just going after those very critical issues. So being able to filter by vulnerability severity is a key way to reduce the amount of noise being fed back to the development team. I keep on referring to the development team, and it's certainly the case that we have not intended intelligent orchestration or code DX to be used directly by the developers. The whole idea is to make app security seamless, make it invisible to the developer and to the development team. And so to that end, the key thing that intelligent orchestration and code DX support is this ability to shift left. The way that's done is by integrating directly with bug tracking systems and with source code management systems. So for example, when I take data from these reporting tools, the tools themselves now can generate SARIF. SARIF is a standard format defined as for static analysis reporting interchange that allows us to export data in a way that will feed directly into GitHub. Right, GitHub has a tab for security right in the area where the developer is looking at their code and their files, and lets them see feedback from these testing tools right where they normally think about the code that they're looking at. So being able to feed the data right into the bug tracking system, that's a key capability. And the second one, a different way of running the SDLC, is to feed that data right into the issue tracking system, the bug tracking system. So if you're using Atlassian or Rally or take your pick, CollabNet of issue tracking systems, being able to feed that data so that when a developer thinks about what work am I going to do next, they're looking directly at a feature request, a defect, and a software security issue prioritized, so they make sure that critical security vulnerabilities are fixed first, and then high severity or high impact defects next, and then they might get down to the next feature request from the business. So this idea around feeding into the bug tracking or issue tracking system so that they've got a unified view of new work, enhancement work, defect work, and security work is a critical aspect here of shift left. When the developer's working, they'll naturally work in an IDE, in an interactive development environment. So we provide an IDE plugin that allows the developers to directly access open source and static analysis tools. These tools are being tuned to run at the pace of the developer. So we're just coming out now with new capabilities, new rapid scanning capabilities that work at the pace of the developer. Our latest static analysis engine is able to run in the sub-second time frame, meaning it operates at the speed of a a spell checker on the source code. So that's really impactful, because it means as the developer's writing code, before they've even thought about checking it in and issuing a pull request, they can have done a preliminary scan and identified and remediated issues, mitigated issues that otherwise would be, going into the pull request and waste time with the reviewer and do an extra turn on the build. They can fix them right there and then as they're writing the code. These are lightweight checks, so they're tuned to the nature of code that may never make it into production. There's no point running every single check out there, policy, compliance, etc. Again, intelligent orchestration is able to tune the level of checks to minimize what's reviewed that really is relevant right to that point of initial code writing and code checking. So those policies can then define GitHub actions that decorate a change into the pull request. So they can document for the reviewer, here's what's been changed, here's the findings from the security tools, so that the reviewer can look at them and say, hey, we like to code this way, we like to address vulnerabilities another way. For example, we always need to make sure we use these rapid crypto libraries, right? So these are things that can be done directly as the code is checked in, and then prioritized in terms of the vulnerabilities that match our organization's security policies. So again, with intelligent orchestration, by policy as code, define that only the criticals and highs, for example, are pushed into that tab that we're showing here in the GitHub view. If you're using the IDE plugin, you're going to get direct guidance on how to remediate the issue. So this new static analysis engine that I was referring to, it can check source code. It can also check infrastructure as code. So as you're defining things like Terraform or something like that that define the configuration of cloud deployment, you can run security checks, configuration checks against the infrastructure that you're going to be deploying on. So this allows you to not just harden the software that you're writing, not just make sure that the open source that you're using is vulnerability free, or at least critical vulnerability free, but also the way that you deploy it in the containers isn't leaving some port open or some other security configuration that you have a policy that you want to ensure is enforced. So kind of bringing it all back together, bringing it up to the top. As I said at the start, my whole goal through this session was to talk about being able to address the skill shortage associated with testing application security, which is the #1 vulnerability to software being deployed in production. With the need of the business to run faster, we desperately need to use tools to automate. Devops has defined a cultural structure around how the teams are organized, which has then led to automation of code pipelines with CI/CD tools. We're now trying to incorporate the application security tools, which may not have originally been designed for that cadence. Intelligent orchestration allows you to define the policies of what is tested when, that matches with the nature of the change and the risk associated with the thing that was changed. So it optimizes the testing that's run. It can run Synopsys tools. It can run third-party tools. It can run open source tools. And all of these tools merely serve to generate data, telemetry about the vulnerabilities associated with the software that was being referred to. CodeDX is able to aggregate all those findings and keep track and show directly to the developer in the issue tracking system, in their IDE, what findings they should fix now and which they should fix soon. It's able to keep a record that shows that the AppSec team can use to report very simply and easily when was a piece of software tested, how was it tested, what were the findings, and what was done about those findings. So it's a record for them that supports audit and compliance. And ultimately, over time, allows us to bind in manual testing, pen testing, other kinds of testing services, so we can look at adding in different kinds of security testing tools as we change the nature of the software that we develop and how we deploy it. The security program gradually expands. So Synopsys offers not just software tools, but it offers software testing services. So we're able to security test code that you write. We can do pen testing, mobile application testing, cloud configuration testing, all kinds of testing services. And we can assess your AppSec program. So we have a way to come in and talk about, we keep track of the best practices in the industry, and we're able to come in and do an assessment with seasoned auditors that can review where you're at, discuss the differences of approaches that you have with culture and tools and process to meet those objectives that you've explained to us, and define an action plan, a maturity action plan that will get you to where you want to be. That, whether it's installing product security champions, helping with training those product champions, whether it's adding in a new process or adapting a process, for example, for cloud security, cloud configuration security, or indeed doing a regular pen test, a scheduled pen test once a quarter, or every major release, or every minor release that touches a critical piece of software, we can support that. So it's not just testing, it's a complete AST portfolio. And today it's really optimized to running at the speed of DevOps. So my recommendations around how to get the most value from app security testing, really make sure you equip developers. When you equip developers, that means training them, right? If we're going to develop a new application, let's decide from the outset what security means for that application based on what it is. Is it a set of APIs out on the public internet? Does it have personally identifiable information in it? Would information leakage, data exfiltration be really problematic for the business or create risk and liability for your clients? We need to decide upfront when we're building software what the threat analysis is for that software, and therefore what the testing approach is. And based on that testing approach, then equip the developers to do that testing efficiently. Testing the code as they code it, and providing fast, actionable guidance back to the developer in the bug tracking system, in their IDE as they write code, or when they open up a file, showing directly feedback about the state of that code. As DevOps team members, you're responsible for building and managing the DevOps toolchain. Make it easier to manage the breadth of test tools that are incorporated into these systems, and provide controls to enforce policies whilst driving high degrees of automation so that the execution of the test is optimized to the right test at the right time at the right level. That will allow us to minimize the test time, but ensuring that we're managing risk defined by the policy. It will allow us to automate and enforce the policy without having to go and wrap people's knuckles when the right testing wasn't done, without issues about running too many tests, spending too much money in compute running all these tests. We can really optimize it to the right level. And then as we transition across to AppSec, really thinking about how we provide feedback. So we've got the correlation and prioritization of findings directly to the developer, so really fast feedback, whilst creating an aggregate view, a consolidated view that allows us to keep track of the AppSec program. We can answer the questions about when tests were run on a piece of software, what was found and what was done about it, and then provide that true visibility into risk that allows us, it gives us the insights over time to tune our approach to security. Is now the time to add a new test tool or a new test type? Are we seeing something about coding in a particular language or building APIs, or as we build serverless versus larger monolithic applications, does that change the nature of testing and the nature of risk associated with the software that we build? Provide IT security the insights to define policies, tune policies, and ensure that action is taken on workflows. That's the end of the prepared information that I had. I want to thank you very much indeed for taking the time. And Charles, I'm wondering, are there any questions that have been raised that we might want to address at this point?
Yeah, we have some questions, but I just wanted to mention that, Simon, you had some great information, especially your value recommendations at the end. So I've been an analyst who's covered AppSec for 20 years, and I thought the presentation was spot on. As you mentioned, the real key in today's business world, especially when it comes to security testing, is that it can't negatively delay software development, right? That software is developing so fast and needs to be fielded. But most of the tools aren't designed for this DevOps world we live in. So I thought you laid out perfectly how Synopsys is optimizing this AppSec testing and policy as code.
That's right, Charles.
Yeah.
You're dead on. Your experience here is very similar to mine. And I think the other thing we sometimes forget is that it's not just like the forward happy path of software through the pipeline. That's ideal. But it's also the case that we find vulnerabilities in production or new vulnerabilities show up. Mm-hmm. And so it's not just when we release code that we can do so in a kind of straight through processing manner, but also that we shorten the time to remediation, right? That when a new vulnerability occurs, and it will, we don't control it, hackers are attacking us, or new vulnerabilities are found, and we need to be able to turn very quickly. So it's also been made abundantly clear to me by vendors that are building critical software that's in print systems and printers and other parts of critical infrastructure, that it's not just the ability to build software right first time, it's also the ability to turn very quickly and address and remediate a new issue that wasn't even in existence, wasn't understood at the point of development. So I think, you know, your point is spot on there. It really is about speed, but it's also about responsiveness.
Yeah. And I just want to remind our audience again that if you want to gather additional information based on today's presentation, you can always go to the handouts tab and see what Synopsys has to offer. And we do have some time for some questions, so let's get to a few of those. And the first one I get from Daryl, and he wants to know, can you normalize non-Synopsys tools easily by vulnerability type and other metrics?
Absolutely. So this is, the reason I say that so emphatically is that this is a fundamental shift that we in Synopsys SIG are going through, is this shift from thinking about, you know, we have best of breed tools, which is really kind of how we thought in the past, to we are going full open, right? So intelligent orchestration is designed to run with any testing tool. If it has an API, if it's callable and generates data that we can get to, then we can incorporate it into the pipeline. Intelligent orchestration is fully open, and then CodeDX is fully open. So we can normalize data from open source tools, from third-party tools, to the extent that we understand it. And, you know, it's basically handling effectively unstructured data to normalize the vulnerability type and other metrics. So the other thing that intelligent orchestration will do, for example, is allow you to compute metrics like defect density. So by looking at how much code was changed, how much code is in the whole system, what was the proportion of change, how many vulnerabilities are being found based on the amount of change, or in a particular code area with, you know, this amount of code, we can generate other metrics that are not, you know, kind of out of the box. These tools are extensible, they're flexible, and they are not targeted. Their design center is not the 3 or 4 Synopsys tools that we're well known for. It's the 60 or 70 tools that we see commonly in CI/CD pipelines. So this is a big change for us.
So that was kind of the question Beverly has, and maybe it's, you know, maybe they're too big, but she's kind of curious what AST tools, and I suspect that it's both static and dynamic tools that intelligent orchestration supports. Is there any specific set or group of those that you're supporting, or how does that work?
Yeah, so this software has been developed. It originated in our consulting team where they were working with clients for many, many years. So the flexibility around deployment models is very high. I think some of what Beverly may be getting at, I mean, obviously, yes, it can incorporate manual testing, things like pen testing, you know, open source tools, custom tools that you've written, static tools, dynamic tools, interactive tools, all of those, because it can choose where in the pipeline that execution occurs. So one of the key decisions is, you know, I can test software when you write it right up front because you wrote the code. I can test open source at the point that you declare that it's part of the build. I can test a container at the point where you say this software is going to be, you know, provisioned in this container. So I need to test the lower levels of the container. What's the Linux, you know, operating system in the container? What's the middleware built into the upper layers? And then what's the application layer you put in on top? So all of that applies. But deployment models around I/O are kind of interesting. Some customers use I/O, so it's a set of containers that will run against a typically containerized pipeline, right? So there might be Jenkins in a container, Jira in a container, all of that in a VPC. So it's designed as a set of small, lightweight containers. There's 4 or 5 of them that connect into the different parts of the pipeline based on the activities. There's the policy engine, there's a workflow engine, there's an insights engine, and they, you know, correspond with the different phases of what's going on. Some customers do in-pipeline testing. That is to say, they run the test directly in the development pipeline. Other customers run it in a separate security pipeline. So they say, yeah, the main pipeline is running super fast. It's got some open source tools that are running at the speed of the pipeline. And then separately offline, nightly, for example, I'm running a full analysis of open source and static as an example. So there are real choices about what you do on the dev branch, the feature branch, the release branch, and the main branch that relate to feedback in the pull request, whether you allow merge onto main, whether you allow propagation of main to SIT and UAT. Am I going to pause the build, stop the build? So there are very different deployment models that we support, and all of those can be defined with policy as code. So no coding required. And then we're building up a pattern of libraries that support these different deployment models. So it's either on-premise, so it happily runs, on-prem, build environments for legacy apps, or it runs natively in the cloud, and indeed can call other AST tools that are SaaS-based. So you may be using other security tools, not from Synopsys, for example, or you might be running Polaris, which is SaaS-based, or Black Duck Hub, which is SaaS-based. So it can call SaaS tools, upload the data, get the results back, and then incorporate them in. So there's a really high variety of deployment models. We haven't yet found a deployment model that we don't support.
Okay. So Daniel has an interesting question, and he says it's kind of a follow-up to Daryl's. And it's kind of related to an issue of the multiple tools. And some of those tools might have different severity rankings of a vulnerability. So how does CodeDX normalize that? Is there a process, or does it manually have to be configured to change? So the quick short question is how does CodeDX normalize differences in these severity ratings of vulnerabilities?
That's a great question, right? So the normalization piece is exactly what is defined, right? Mediums, quote medium severity being found, might be in different tools in different ways. So they're presenting as medium, but then one is the carpooling SharePoint, and the other is, has social security number and other personally identifiable information. Medium might mean something very, very different in that regard, depending on the API, the data, the application. And so that's what's normally handled in triage. And again, I mentioned earlier that triage can be something that is done by a product security champion embedded in the team. So they have that context. They're working right in the product team. They have that context. They know how to think about that. Or it can be handled by the AppSec team, where threat analysis guides them around what the implications are. But either way, in that triage process, CodeDX supports that, and it retains that triage so that you're not continually having to reduce the noise of stuff that's unimportant in the carpooling SharePoint and continually elevate issues in the social security database. On top of that, the machine learning piece then watches that behavior. So the machine learning model starts to learn that issues associated with that software are escalated manually more often than in the carpooling SharePoint. So it actually provides automated support then, so that again, you're not continually having to manually do that update.
Okay, so we have time for one more question, and I'm kind of interested, and it was brought up, is your customers, when they deploy intelligent orchestration, is there different deployment models? I suspect we're talking about cloud or on-premise or some hybrid situation. So how are your clients looking at deploying the intelligent orchestration?
Yeah, great question. We have customers that are dealing with legacy applications. They're commonly on-premise, so they're installing the software locally, in containers right against their kind of classic pipelines. These are more typically, the SDLC looks more kind of waterfall. There's like clear handoffs. Code is written, code is built, handed off for test. Maybe there's a separate branch then where AppSec does their testing different from the functional and integration testing that the QA teams do. So that's one mode in which we commonly run for legacy applications. I see this with ISVs. I see it with companies that have traditionally run a lot of software that they built. This is financial services and healthcare. And then there's a separate, almost like quite distinct mode where there's a whole new set of organizations or companies that have traditionally not thought about software as their bread and butter. It's kind of interesting. Telcos, new media, weren't really software companies before. They were truly hardware networking companies. And now increasingly they're building software services on top of those networks. The value add that they sell to you and I for mobile and home-based networking is the services on top of that. And so increasingly they're being forced to be software companies, which means they don't always know what they're supposed to be doing. They haven't been brought up with security and quality as a fundamental cultural issue for them in software. And separately, they may well be building very modern application architectures. That is to say, they're cloud native in the way the software is deployed, and cloud-based in terms of how the software is developed. And so in that case, they're looking for tools that run natively as containers in the cloud and plug in directly to the pipeline tools that they're using. So they might well be using Amazon's code pipeline or Azure's Devops tooling, and therefore they're looking for software that connects directly into those native apps for code repositories, binary repositories, issue tracking tools, whether they're deploying a container of Jira and Jenkins in AWS, or whether they're using the native tools that Azure and Google and so on are using. So that's creating two quite different paradigms. One is the more kind of classic on-prem, which itself is starting to modernize. And then there's the very, very modern, where their expectations around performance are high, around usability and integration to their SDLC is high, and integration requirements to modern CI/CD cloud tooling is like paramount. I mean, it's non-negotiable. It's a must-have.
All right, thank you, Simon. We're pretty much out of time right now. I do have to announce the attendees who have been selected for the $25 Amazon gift cards, and they are Bianca P, Cal H, Vasanta H, Carlos M. So you will receive an email at the email address you registered for this webinar with. And if you're like me and you have 7 emails, you'll have to figure out which one you use to register with. And you also need to check your spam filter if you don't receive the information soon. And Simon, I want to thank you again for your presentation. Again, spot on. I think we used that word a couple of times. Thank our sponsor, Synopsys. And if you want to get some more information, go to synopsys.com. And I also want to thank you, our audience, for taking an hour out of your day to spend it with us. And goodbye for now, and may the fickle finger of fate be kind to you.
Stay secure, everyone. Stay safe. Thank you.